Greetings everyone. In this video, we'll be discussing about the substation equipment, rather a connecting equipment, that is the cable, electrical cable. And by the end of this video, you will be able to know the different types of cable, the classifications, uses of this different types of cable in substation, and how these cables are being laid, and what are the cable accessories. So basically, electrical cables are the backbone of the substation. It helps in providing the power, control, protection, communication, and measurement connectivity between various equipments. The various equipments such as our transformer, our CT, our PT, breaker, isolator, battery system, DG set, AC distribution, station transformer, all these hardware components which are there in the substation, in the switchyard, and the control panel what we have already discussed, and the control panel and the hardware, the software integration is being done with the cables, with the help of cables. And a cable is made up of one or more conductor that may be solid or stranded and has its insulation, and together it is called as a core. So basically, there are four essential parts of a cable, that is the conductor, the insulation, a sheath, that is the protective armor around the conductor to protect them against mechanical damage, an oversheath or protective harness around the complete cable to protect against its from external influences. Here the pictorial representation, you can see the conductor, then the insulation, the inner sheath, the bedding, and the armoring, and the outer sheath. Based on the rating, based on the purpose, based on the use, applications, these cables can be of different type. And next we'll see the classification. So based on conductor, it may be solid or stranded, it may be copper or aluminium, the conductor material. Similarly, based on the insulation, paper, oil, PVC, XLP, or EPR, or based on the voltage, it can be LT cable, HT cable, ST cable, or EHT cable. That is the rating we have specified. Then comes here in substation, in switchyard, we have these four cables for electrical uses and another for electronics purpose. There we have from 415 volt to 220 kV and above. Those are power cables. The purpose is to transmit or distribute power. Similarly, control cables, they are used in circuit breaker, isolator, initiation, and interlocking circuits. Protection cable, CT, PT, secondary circuit, and relay connections. Instrumentation cable for measurement and monitoring the signals. Communication cables for SCADA, PLCC, Ethernet communication. Optical fiber cable for high speed communication and protective signaling. DC cables for battery and charger systems. And here also we have mentioned what is the size and specifications based on the application, where it will be used, and up to what rating we can use in the purpose of these cables in an elaborative way. And most of you knowing the power cables. Here in this video I'll be just focusing a little bit about control cables. So these are multi-conductor cables used for automation instrumentation applications and are often rated around 1.1 kV or 1000 volt. And these are used in RCT circuits and controlling purpose for the metering and the other circuits as seen in the earlier slide. This is the cross-sectional view of a control cable, and these are the specifications. Here for a polycab manufacturer, I have taken the data. You can see the voltage grade, the material, the insulation, inner sheath, armoring, electrical parameters, impedance per ohm, impedance of cable ohm per kilometer, cable capacitance, temperature rise, and continuous current carrying capacity at 30 degrees Celsius, at 40 degrees Celsius, like that. The bending radius, because we cannot, as I said, it allows us for connecting the hardware setup that is there outside the control room in switchyard and the panel that is there in control room. So it's not in a straight line, several bendings will be there, and how much bending can be done through the cables, that also is being specified by the manufacturer. Here you can see a diagram of the cable vault, the cable room underneath the control room. That is the cable coming from switchyard, enters in the cable vault, and then is being segregated and is being fed and routed to the control room. And the selection of the route are uh, very much essential and very much cost effective. It has to be cost effective also, and should be uh, the safety aspect, that is it should be away from other running gas pipes, water pipes, telephone cables, and cable joints and end terminations should be uh, um, ensure maximum safety, because they carry electrical power and signal which can be, if at all it can be disturbed, then it can lead to a catastrophic failure. So these are the four types of methods by cable for laying: through cable trenches, through cable trees inside control room, and underground burials for long outdoor run, and RCC cable trench with cable support. Here you can see in the RCC cable trench, through different type of cable tray, we are laying different cables, that is the power cable, control cable, and data cable, that is being laid according to the IS standard mentioned here. Next comes about the termination, from the starting from the equipment to the panel. So the glands are very much crucial part for proper terminations. Cable glands, they are of different type, and as I have shown, and cable locks are used for connecting to the appliances, surfaces, or mechanisms. So here these are the parameters for selecting proper cable depending on the application, that is the current carrying capacity, voltage drop limit, short circuit withstand capability, fire resistance, and flame retardancy, because it carries either power or data, whichever can be, if it will disturb, will lead to a severe damage. Similarly, shielding against electromagnetic interference, and uh, it should be easy for maintenance and future expansion. Thank you for your patient hearing.